I have a couple seashells and rocks. I'm going to want to know the total amount of all of them. I place them all down. I'm going to use my wonderful tool right here to divide them instead of counting them all at once. I have 1, 2, 3 going down, which is my height, and I have 1, 2 going across, which is my length. 1, 2, 3, 4, 5, 6. 6 on this side. I have 1, 2, 3 going down and 1 going across. So I have 1, 2, 3. Altogether, 6 plus 3 is what? It's 9. This week we're going to learn about the distributive property and area. Get ready. Welcome to week 7, 3rd grade. It is time for our math lesson. Miss P, Miss Baloney, and Miss Reed are excited that you are here. Week 7 math expectations. Step 1, we have our math standards posted below. In step 2, today I can apply the distributive property to area models and find the area of combined rectangles. By the end of the week, I will be able to compare perimeters of rectangles that have the same area. Step 3, our hook is the same as last week, APT. The A stands for area in the plane figures. The P stands for practice counting each unit square. And the T stands for take time to multiply and add sides. Step 4, materials that you need go as follows. 1, a math journal. Write down all your math vocabulary words that you will learn for the week. 2, a pencil. 3, whiteboard and eraser, only if you have it. And square tiles, only if you have it. Let's get ready for our weekly song.
Come across a factor that is bigger than one. Just use your known facts of multiplication. But what if a factor goes beyond what you know? Distributive property will help you solve those. Take the big factor, break it up, then after multiply the parts by the other factor. Add up those parts, put them back together. Now you have the product, what you did was clever. That's distributive property, yeah, break it up. It ain't just a novelty. Now wake on up, it means that you're scholarly. Multiply it up, that's distributive property. Yeah, add it up, that's distributive property. Yeah, break it up, it ain't just a novelty. Now wake on up, it means that you're scholarly. Multiply it up, that's distributive property. Yeah, add it up.
Here's one example just in case you're in need. 18 times 7 is scary indeed. Take that 18 and break it up into 10 and 8. You ain't in a rut. Multiply them both by the factor 7. You get 70 and 56, you're slaying. 70 plus 56, 126. You're done with this problem, ain't nothing you can't kick.
That's distributive property, yeah, break it up. It ain't just a novelty. Now wake on up, it means that you're scholarly. Multiply it up, that's distributive property. Yeah, add it up, that's distributive property. Yeah, break it up, it ain't just a novelty. Now wake on up, it means that you're scholarly. Multiply it up, that's distributive property. Yeah, add it up.
I hope you enjoyed our song for the week on the distributive property. It was great, right? So once again, for week 7, you are going to be able to apply the distributive property to area models and find the area of combined rectangles. By the end of the week, I, that's you, will be able to compare perimeters of rectangles that have the same area. Let's go over our vocabulary words of the week, some of the words we learned last week, and then I'm going to add 2 new words. Perimeter, the distance around a figure. Unit square, 1 unit or 1 square. Once again, they both mean the same thing. 1 square or 1 unit. Our rectangle, it has 4 right angles. We have our shape, a polygon, which is a closed plane figure having 3 or more sides. Area, the measure of the number of unit squares to cover a flat surface. Distributive property, it lets you multiply a sum by multiplying each add-in separately and then add. We have our length. This is an example. The length in a shape is always the longest part. And lastly, width. The width is the shortest part in a shape. It's time for our next part for our week 7. Area using the distributive property. Make sure you have your math journal so you can write down my example, and then you will be doing one on your very own. Use the distributive property to find the area of the rectangle. So right here we have our rectangle. Going all the way across is our length, and then going down is our width. Ashe? Ashe. So the first thing that I'm going to look at is the width going down. I have 3 centimeters. I have 3 already written down for you. The next part, I'm going to look at the total amount going across of unit squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how I have 10 centimeters, so I'm going to write 10. Now, I use a thicker black line because I want to divide this shape so I can add it a little bit easier for myself. So for the first part, I'm going to look at the first part, which is in red. 3, the width going down, times 3, the length going across. Let's look at the next one, all in blue. 3 centimeters going down and 7 centimeters going across. So now I can calculate for my next step. 3 times 10 is what? Skip count by 10, and I will get 30. Let's multiply these two numbers. 3 times 3 is 9, and 3 times 7 is 21. 21 plus 9 is 30. Do we end by just saying 30? No, 30 centimeters. You want to know, does this number match this number? And it does. That's how you know you have the answer correct. Now, get ready to solve on your own. Use the distributive property, once again, to find the area of the rectangle. I'm going to give you a couple of minutes to write this down, and then we're going to come back together to see if your answer is the same as my answer. Good luck. I know you can do it. How did you do? Did you get the same answer as me? Let's go over it. 3 times 5, the width going down, length going across. 1, 2, 3, 1, 2, 3, 4, 5. 3 times 5. I have my dark line right here. 3 times 3, and then 3 times 2. Once again, you can look at the colors to see how to separate it. 3 times 5 is 15. I got this answer by skip counting. 3 times 3 equals 9. 3 times 2 equals 6. So now we want to add. 9 plus 6 equals what? 15 centimeters. So our area is 15 centimeters. Does this number match this number? Awesome. Good job. Once again, you are going to be able, by the end of the week, be able to compare perimeters of rectangles that have the same area. Have a blast, guys. Until next time.